This lesson is going to be about combinations of functions and composite functions. This is section 1.8 in your textbook. Our essential question is, how do you add, subtract, multiply, and divide functions, and what are composite functions? So let's start with the sum of two functions. So let's say I've got two functions, f and g, and I want to add f plus g of x, okay? That simply means you take the f of x function, you take the g of x function, and you add them. So let's look at an example. So let's say we've got a function f of x, and that is simply equal to 2x plus 1. And we have another function g of x, which is equal to x squared plus 2x minus 1. So if I wanted to find the sum f plus g of x, I would simply take the f of x function, which is 2x plus 1, and I would add it to the g of x function, which is x squared plus 2x minus 1. And the result would simply be x squared plus 4x. And then if I were asked to take this new sum function, f plus g, and find out what the value would be at x equals 3, I would simply say, well, f plus g of 3 is equal to 3 squared plus 4 times 3, or 21. Now I would like you to pause the video, and given f of x is equal to x squared and g of x is equal to 1 minus x, I'd like you to find f plus g of x and then evaluate that sum function when x equals 2. And you could put your answers in the drop box. Well, now that we know how to handle the sum function, the difference function is very similar in that the only change is now that we are subtracting the two functions. So for example, if I wanted f minus g of x, I would simply take the function f of x and I'd subtract from it the function g of x. So let's look at an example. And for this example, I'm going to use the same f and g functions that I used in my previous example. For example, f of x is going to equal 2x plus 1, and g of x is going to equal x squared plus 2x minus 1. So now I want to determine what is f minus g of x. Well, I simply take my f of x, I take my g of x, and subtract g of x from f of x. So initially the setup is very similar to what we had before. We have our first function, f of x, and we have our second function, g of x, and we're simply subtracting them. Now, the only thing to be careful of, though, is this minus sign right here. Okay, and that's the reason I purposely put x squared plus 2x minus 1 in parentheses, because I am subtracting. That means every sign inside the parentheses has to change. So now I have 2x plus 1 minus x squared minus 2x plus 1. And when we combine the like terms, we end up with a final answer of minus x squared plus 2. Well, now we can do the same thing we did before, and we can determine what is the difference function for a particular value, in this case x equals 2. So if I want to know what is f minus g of 2, I would do the following. I would plug in 2 for x, and so I'd have minus parentheses 2 quantity squared plus 2, and our final result would be minus 2. Now, I would like you to again pause the video, and given the fact that f of x is equal to x squared and g of x is equal to 1 minus x, I want you to find the difference function f minus g of x and then evaluate this difference function at x equals 3. Post your answers in the drop box, then you can continue with the video. Next, we're going to talk about the product function. Now this is when you want to determine what fg of x is. So you simply take the function f of x and you multiply it times the function g of x. So let's look at an example again. And in this case, I'm going to say that f of x is equal to x squared and g of x is equal to x minus 3. And I want to find fg of x. So in this case, you would multiply the f of x function, namely x squared, times the g of x function, namely x minus 3. And your result would simply be x to the third minus 3x squared. So again, if you want to evaluate this product function, fg, at x equals 4, 4 to the third power minus 3 times 4 to the second power. And the result would simply be 16. So once again, I'd like you to pause the video, and given the fact that f of x is equal to x squared and g of x is equal to 1 minus x, I'd like you to find the product function fg of x, and then to evaluate the product function when x equals 3. Again, post your answers in the drop box. Once you're finished, you may resume the video. Finally, let's talk about the quotient of two functions. So now, as I said, we're talking about the quotient function, which is f over g of x, which simply means take the function f of x and divide it by the function g of x. Now, obviously, one thing you have to be careful of with the quotient function is that g of x cannot equal 0. So with the quotient function f of x over g of x simply cannot equal 0, because then you'd have division by 0. So let's look at an example. In this case, f of x is going to equal x squared, and g of x is going to equal 2x. And I want to know what the quotient f over g of x is equal to. So once again, we simply take the f function, or the f of x function, which is, in this case, x squared, and we divide it by the g function, which in this case is 2x. So the result in this case is simply x over 2. Now again, if we were asked to evaluate this quotient function at a particular value of x, say x equals 2, the result would look something like this, where you would simply plug in 2 for x in the quotient function, which is x over 2, and you'd end up with 2 over 2, or 1. Now I would like you to once again pause the video, and given the fact that f of x is equal to 6x squared and g of x is equal to 3x, I'd like you to find the quotient function f over g of x and then evaluate the quotient when x equals 2. Post your answers in the drop box, and then you can continue watching the video. Now the last thing that we're going to talk about in this lesson is composite functions. So what exactly do we mean by a composite function? Now the way this is written can go a long way for a student to understand what exactly a composite function is. Now my preference is to write it as f of g of x. So basically what you're going to do is you're going to take the function g of x and substitute it for x in the function f. Let me explain this via an example. So let's assume we have two functions, f of x, which is equal to x squared, and g of x, which is equal to x plus 1. So we have an f function and a g function. So let's assume that we want f of g of x, okay? So I'm going to look, what is g of x? So I simply take the function g of x, which was x plus 1, okay? And I substitute that in for x in the f function. So I take x plus 1, and now this becomes f of x plus 1. So everywhere where I used to have an x with the f function, I'm going to substitute in x plus 1. So the result for f of g of x is simply equal to x plus 1 quantity squared. Now, what would be the difference if I were to ask for g of f of x? In this case, I would take the function f of x and substitute it for x in the function g. Now I would have g of x squared. So with the g function, every place that I had an x, I would substitute an x squared. And my answer now would simply be x squared plus 1. So see the difference between f of g of x and g of f of x. Now, you should be aware of one additional thing, and that is a number of books use a different nomenclature or terminology for a composite function. I don't happen to like it, but it's not much we can do about it. And what a lot of books do, and ours is one of them that does this, is instead of writing it as f of g of x, they write it as f, and this is in parentheses. They write it as f with a little open circle, but to me this makes it look like the word fog, f of g of x. And this is the same thing as our writing it f of g of x, okay? My preference is the second version because it's clearer as to what you are actually doing. Obviously, a similar result, similar way, they could say g of f of x, but my preference is to write that as g of f of x. Okay, now I'd like you to take the functions given in the example above, where f of x equaled x squared and g of x equals x plus 1, and evaluate the composite function f of g of x at x equals 2, and post that answer in the drop box. Thank you.